Welcome to G Fun Facts Online. Today we're talking about the unsung workhorses of our global economy, the massive, boxy ships you might call floating garages. Officially, they're known as roll-on/roll-off ferries, or RORO for short. Their principle is brilliantly simple. Vehicles just drive on and drive off. But behind this simplicity is a world of incredible engineering, high-stakes economics, and a dramatic history that has fundamentally changed safety on the seas. So let's get into it. The idea of rolling cargo onto a ship isn't new. It actually dates back to 1851 in Scotland, with the Firth of Forth ferry. This wasn't for cars, but for trains. The ship had railway tracks on its deck, allowing entire train carriages to be rolled aboard, creating a floating bridge where a real one was impractical. But the concept's true potential was unlocked by war. During World War II, the Allies needed to get tanks, trucks, and other vehicles onto enemy beaches fast. They developed the Tank Landing Ship, or LST, which featured a huge bow door and ramp. This allowed armored vehicles to drive directly onto hostile shores, proving the incredible efficiency of the RORO design on a massive scale. After the war, the commercial world took notice. The post-war economic boom and the explosion of car ownership created a new demand. Before, RORO, taking your car across the sea meant having it slowly and expensively craned into a ship's hold. RORO ferries changed everything. In 1953, the port of Dover introduced its first RORO service. Car handling numbers skyrocketed from 10,000 a year with cranes to 100,000 in the first year of RORO. For the freight industry, this was revolutionary. A truck could drive onto a ship in one port and drive off in another, often just minutes after docking, slashing transit times and handling costs. This seamless link between road and sea cemented RORO's place as a vital tool of global trade. Now, let's look at the anatomy of these giants. At the heart of a RORO are its massive doors and ramps. You have external ramps at the stern, bow, or even the sides, which act as bridges connecting the ship to the dock. On dedicated routes, bow and stern doors allow for a drive-through system, making loading and unloading incredibly fast. Inside, a network of internal ramps distributes vehicles across multiple decks. Many of these decks are hoistable. This is a marvel of flexibility. For one journey, the decks can be lowered to create space for thousands of cars. For the next, they can be lifted to create double-height spaces for tall cargo like trucks and massive construction equipment. But the very feature that makes a RORO so efficient, its vast open vehicle decks, also creates its greatest engineering challenge: stability. To allow vehicles to maneuver easily, these decks have few or no internal walls or transverse bulkheads. This creates a huge, uninterrupted space, which is incredibly vulnerable to something called the free surface effect. Imagine this: if a large amount of water gets onto the vehicle deck, either through a damaged hull or a leaking door, it can slosh from side to side as the ship rolls in the waves. Think of trying to carry a large, shallow tray full of water. A small tilt can cause the water to rush to one side, making it very difficult to keep level. On a ship, this moving mass of water works against the vessel's natural ability to right itself. The momentum of the water can amplify the roll, leading to a catastrophic loss of stability and causing the ship to capsize with terrifying speed. Adding to this, RORO ships have a naturally high center of gravity, because all that heavy cargo is loaded onto decks high above the waterline. This makes them more sensitive to heeling forces from wind and waves. The structural design of these decks is also a feat of engineering. They aren't just floors. They have to support the immense weight of hundreds of vehicles and the dynamic forces they create as the ship moves. Then there are the hidden dangers. During loading, with hundreds of engines running, the enclosed decks fill with toxic fumes. Massive ventilation systems are crucial, using powerful fans to constantly supply fresh air and exhaust contaminated air, and fire is a paramount concern. Every vehicle is a potential fire source with its own fuel and electrical system. The open decks that make loading easy also mean a fire could spread incredibly quickly. So these ships are equipped with extensive fire detection systems and powerful suppression tools like water deluge systems, high expansion foam, or CO2 flooding systems. The rise of electric vehicles, with their own unique fire risks, has led to even stricter regulations and new firefighting equipment. So how big is the RORO market? It's huge. In 2024, it was valued at over $27 billion and is projected to grow to over $46 billion by 2033. This growth is driven by global trade, especially the automotive sector. Over 70% of all RORO cargo is vehicles, and in 2023 alone, over 22 million vehicles were transported by sea. The main trade artery is the Asia-Pacific region, which dominates the market. Driven by the auto industries of Japan, South Korea, and now China, this region originates about 55% of global car exports. Europe is another major hub, with a dense network of short-sea routes vital for the continent's just-in-time supply chains. The transatlantic route between Europe and North America is also a critical artery. And it's not just cars. RORO ships are essential for moving what's called high and heavy cargo, things like giant construction and agricultural machinery or components for wind turbines. The market is dominated by a few major players like Norway's Wallenius Wilhelmsen, Italy's Grimaldi Group, and the big Japanese lines NYK and K-Line. These companies are constantly updating their fleets, with over $4.5 billion invested in new, often LNG-powered vessels between 2023 and 2024. The economic advantages are clear: speed, lower port costs, and less risk of cargo damage. But there are challenges too. These ships are expensive to build, they require specific port infrastructure, and their reliance on the auto industry makes them vulnerable to economic downturns. However, the story of RORO is not just one of efficiency and economics. It is also a story of tragedy and the hard-learned lessons that followed. On March 6, 1987, the passenger ferry Herald of Free Enterprise left the port of Zeebrugge, Belgium, with its bow doors wide open. The crew member responsible for closing them had fallen asleep. On the bridge, there were no indicator lights to show the doors were still open. As the ship picked up speed, water surged onto the car deck. The deadly free surface effect took hold instantly. The ferry capsized in just 90 seconds, killing 193 passengers and crew. The inquiry blamed not just individual negligence, but a corporate disease of sloppiness. This disaster was a brutal wake-up call. The International Maritime Organization immediately mandated new safety rules: indicator lights on the bridge for all watertight doors, CCTV on vehicle decks, and the creation of the International Safety Management Code, which forced shipping companies to implement formal safety systems. But 7 years later, an even greater tragedy struck. On September 28, 1994, the passenger ferry MS Estonia was sailing across the Baltic Sea in a storm. The locks on its bow visor, the large section that lifts up to reveal the ramp, failed under the pounding of the waves. The entire 50-ton visor was torn from the ship, ripping the loading ramp away with it. This left the car deck completely exposed to the raging sea. Water flooded in, the ship listed severely, and in less than an hour it sank. Of the 989 people on board, 852 lost their lives. The investigation found that the visor locks were simply not strong enough for the conditions. In response, regulations were tightened again. Stricter design requirements for bow doors were implemented, and crucial stability standards, which required ships to be able to survive flooding in at least one compartment, were retroactively applied to all existing passenger ferries. These two disasters exposed the fine line between efficiency and risk, and forged the robust safety culture and redundant engineering that define modern RORO ships. So what's next for these rolling giants? The industry is on the verge of another transformation, driven by technology and environmental concerns. The autonomous revolution is coming. Companies like Rolls-Royce and Kongsberg are developing systems for remote and even unmanned vessel control. The goal is to improve safety by reducing human error and to boost efficiency. The world's first trial of an autonomous system on a large commercial ship was actually on a car carrier, the Iris Leader, in 2019. At the same time, the push to decarbonize is accelerating a shift away from fossil fuels. While liquefied natural gas, or LNG, is already a common cleaner transition fuel, the industry is looking ahead to zero-carbon options like green hydrogen and ammonia. For shorter ferry routes, hybrid and fully electric systems with large battery banks are becoming the new standard, allowing for zero-emission operation in ports. From a simple floating railway to a linchpin of global logistics, the roll-on/roll-off ferry is a testament to an idea that changed the world. Its journey has been one of continuous evolution, shaped by the demands of commerce and the painful lessons of tragedy. Today, as these vessels become smarter, greener, and safer, they remain a powerful symbol of our interconnected world, the rolling foundation of global trade. Thanks for listening to G Fun Facts Online.